Find the sum to n terms of the following series. Let us begin. So here we have a series whose first term is 1, followed by 3, then we have 6, then 10 plus 15 and the rest of the terms. Now here, clearly this particular series is not an arithmetic series because there is no common difference here. However, there is a pattern that emerges. If we consider the second term, that is 3, and from here subtract the first term, which is 1, we get the value 2. Now, we will take the third term, that is 6, and from here subtract the second term, that is 3, that's going to give us 3. Then take the fourth term, subtract the third term from it, that's going to give us 4. Fifth term minus the fourth term, that's going to give us 5. So the pattern that emerges is this. So if we consider 2, 3, 4, 5 and the terms that we will obtain by taking the difference, these terms are going to be in arithmetic progression. So that means this is the hint that we will be using here to solve this problem. So to begin with, what we'll do, let us suppose that this particular series is denoted by Sn, where Sn represents the sum to nth term or sum to n terms. Now for this, we will be considering the last term or the nth term of the series when we are going to denote it with Tn. Then let us also consider the second last term, which is Tn minus 1. Fine. Then we will consider the same series, and then this time we're going to write the first term below the second term of the previous series. Then the second term, which is 3, we're going to write it below the third term of the previous series. So we have 1, 3, 6, 10 goes all the way up to the second last term, which is Tn minus 1, and the last term, that is Tn. Now we'll be subtracting the two series. So here on the left hand side, we will get 0. Then we have 1 added to, now 3 minus 1, that's 2, added to 6 minus 3, that's 3, 10 minus 6, that's 4, 15 minus 10, that's 5. This goes all the way up to Tn minus 1. Then this is going to be a single term, and then we have negative Tn. We'll transpose this negative Tn to the left hand side to get Tn. This is going to be equals to 1 added to 2 plus 3 plus 4 all the way up to the last term, second last term, Tn minus 1. Fine. Now we have Tn, and on the right hand side what we have is a arithmetic progression whose first term is 1, and the common difference is also 1, and it has got a total of n number of terms. Now we know that this is simply the sum up to the n terms. So that has a standard formula given by n over 2 multiplied to 2 times the first term added to the total number of terms minus 1 times the common difference, that is 1. So here we have n multiplied to n plus 1 divided by 2. So this gives us the sum to n terms, the sum of the first n natural numbers. Now that we have the total number, the nth term of the series, we are ready to find out the sum. So now the sum is n, so that's given by, we have summation tk. All we have done is replace the index n with k, and k goes from 1 to n. Okay, now we have summation tk, but instead of tk, we'll use this nth term of the series. So we'll have half k squared added to half k. All we have done is replace the index n with k, and k goes from 1 to n. So we get half k squared added to half summation of k, where k goes from 1 to n. K is going from 1 to n. Okay, so let's now find out the sum. Now these two sums, so we have summation of k here, k squared. So summation of k squared with k going from 1 to n, this is simply the sum of the squares of the first n natural numbers. So by 1 squared plus 2 squared all the way up to n squared. So that's going to be equals to, we have n multiplied to n plus 1 multiplied to 2n plus 1 whole divided by 6. Next we have summation of k with k running from 1 to n. So here we have 1 plus 2 all the way up to n. This is the sum of the first n natural numbers. So the standard formula is n times n plus 1 divided by 2. So let's use these two formulas. So we have half multiplied to n times n plus 1 multiplied to 2n plus 1 whole divided by 6 added to half multiplied to n times n plus 1 divided by 2. Now we're going to combine the two terms. So for this, let's take n times n plus 1 divided by 2 as the common factor from both of the two terms. So here we will be left with 2n plus 1 divided by 6 added to 1 half. Fine. So that is now going to give us, we have n multiplied to n plus 1 divided by 2. Multiplied to, we have 2n plus 1 added to, we'll have 3, and the common denominator, that's going to be 6. So that gives us n multiplied to n plus 1 divided by 2 multiplied to 2n plus 4. But what we can do, we can take 2 as the common factor. We have 2 times n plus 2 divided by 6. Factoring out the 2 from the numerator and the denominator, that gives us the final sum as n times n plus 1 multiplied to n plus 2 whole divided by 6. So this is going to be the sum to n terms of our series, which is given by 1 plus 3 plus 6 plus 10 plus 15 and the rest of the terms.